good enough. Thank you, sir. Appreciate it.
You're welcome.
Okay, so let's wrap this up. What I demonstrated to you is a process known as modeling. It's another hallmark of science. Okay, it's another hallmark of science. In fact, let's do that demo again. Okay, this is what you observed. Okay, and I told you not to look inside, and with your group you discuss what you think is going on inside, right? So in science we observe a lot. We do experiments a lot. That's the reason why you try to pull strings. That's experimentation. And then you make a model. These are all your models. And even though each group work on his or her own, something is common among all of these models except the one that I made because I purposely did this. Okay? But what is one thing common in all the models? Okay? They are all connected. You see, scientists all over the world, they might be working on the same research, doing separate experiments and so on, but they are observing nature. And they will come up generally on the same model because they are observing the same thing, isn't it? And all of you came up a bit different, but each one of them are interacting somewhere in the middle. This is a bit more complex, but it's a good one, but still interacting somewhere in the middle. So my question to you is, now that you have observed, how do you know what should be the next step in order to know if your model is correct? Without opening it, what should be the next logical step? Yes, sir?
Test all the possibilities.
Test all the How are you going to test all the possibilities? Because you're not going to open it and you can look at all the possibilities there. Yes, sir?
Test your theory.
Okay. How do you test your theory?
You try to make your own model to see if it works.
Exactly. That's the exact word, and I think that's what you're saying. You make your own prototype. You construct your own prototype, right? And that's how engineers work too. Even in the world of, who are my finance majors here? You make your own financial model, isn't it? And how do you know it's right? Then let's see how the market behaves. Are you going to make money out of your model? You see, in the world of geology, I came from the world of mineral exploration. I go to the field, I make my scientific observations, do my mapping, look at the rocks, and then do an additional soil sampling, do geophysical work, geochemical work. I am looking at every bits and pieces of information on the ground. And I use mostly all the different branches of science. But since I work for a mining company, ultimately my boss will say, all right, Dr. Aquino, where are we going to drill? We need to make money, baby. I mean, it's business, isn't it? I'm done with all your modeling. Let's test it. So here are some examples of models in geology. These are what we call ore deposit models. And I'm going to go over them quickly. So these are all examples of ore deposit models of a copper gold. Okay. Another one, magmatic mineral deposits. Another one, hydrothermal mineral deposits, and so on. And even mining engineers will have their own model on how to mine this. And if you actually simply Google, okay, or deposit models, you are going to see a lot of them. And here is what's based on the computer, and many more. So if you are in the field of geospatial system, this is really an application of what you're going to do. And unfortunately, of course, our Institute of Environmental Spatial Analysis specializes on forestry, urban planning, okay, and not a lot will go to the field of mineral exploration, but this is the big thing. Seriously, this is where you make good money. And not only mineral deposits, but petroleum, right? Petroleum. What we call the liquid gold. So these are all examples of models. And even if you look in history, during my time when I was your age, we really don't know how an atom looks like. We have many models of an atom that you've studied in chemistry, correct? Many, many models. But one thing, one model that we know there is some degree of truth, but we still don't know if it's the reality or not, is what we call the nuclear model. Because we have not seen a nucleus, isn't it? We have not. But we know we have done a lot of experiments, and there is some degree of truth in our nuclear model because we have developed actually two technologies. One that can destroy humanity, and the other one that can save humanity. What is the one that can destroy humanity?
Atomic bomb.
Atomic bomb, folks. It's so sad. But it has to stop World War II. But in what way can you use the nuclear model or nuclear theory to save humanity? Nuclear energy, which gives us energy, and one more, let's make it 3. In what way can we use it? It's actually something that you know.
Chemotherapy.
Exactly. Chemotherapy, the radiation being given by radioactive minerals can save our lives. So we have used them. We know there's some degree of truth in this model, probably very close to the truth, but we don't have the technology to actually see a nucleus. But maybe one day. All right? So do you have any questions? So you make sure those of you your cubes, take a photo of them if you have not uploaded it, and then go over our next journal next Monday. Okay? We have some due dates. All right? Have a blessed evening.
Yours.